Students, now we are on the topic of mean value theorem, Lagrange's mean value theorem and Rolle's theorem we are discussing. The topic mean value theorem. In previous class we have discussed about level 2 classwork. In previous class we completed 5 sums. Now we are on 6th sum. This is JEE main question, an important question. Just logical thinking is there in this question. F of x and g of x are differentiable functions in 0, 1 such that given value f of x, g of x are differentiable functions. F of x and g of x are differentiable or derivable, we can say. F of x and g of x are differentiable functions such that f of 0 is equal to 0. F of 0 is equal to 2 he given. F of 0 is equal to 2. On the 0, 1 closed interval he given, such that f of 0 is equal to 2 and g of 0 is equal to 0 and f of 1 is equal to 6. Then g of 1, we should carry g of 1 also 2 given. G of 1 also 2. Then there exists 0 less than c less than 1 such that f of c is equal to f dash c. So what is f dash c is asked. I said that logical thinking is there. 2 minus 0 is equal to 2. Here this value 2 he given, f of 1 6 given and f g of 1 he given as 2. G of 1 he given as 2. 6 minus 2 into 2. 6 minus 2 into 2 becomes 2. So 2 minus here 2 into 0 becomes 2. So this is 2, that is 2. You can say consider, I am saying about, depends upon these two values. Consider phi of x is equal to, consider phi of x is equal to f of x minus 2g of x. F of x minus 2g of x. Now let us write differentiating both sides. Here f of, you can say here f of 0 minus, students you should write here f of 0 minus 2g of 0 is equal to 0. 2. F of 0 minus 2 0 of g of 0 equal to 2. Here f of 1 minus 2 g of 1 also 2. Therefore here you can say phi of 0 is equal to phi of 1, the value 2 he given. Differentiating both sides. Phi of, that implies I am writing here, phi of 0 is equal to phi of 1. Both values 2. Same. So whenever differentiating both sides you can say phi dash of x is equal to f dash of x minus 2 into g dash of x is equal to 0 by Rolle's theorem. Because what I am saying, this is continuous, this is derivable already given. Whenever the function is derivable, it is obviously continuous. So continuous and derivable. Now just to be derivable like this, this phi of 0, whenever we have taken phi of x equal to f of x minus 2g of x, in the same way we got the value phi of 0 is equal to phi of 1, the value is equal. Whenever f of a is equal to f of b, next notation by Rolle's theorem, next notation by Rolle's theorem, we can conclude that by Rolle's theorem. By Rolle's theorem, we can say that phi dash x is equal to, this one is 0. That implies you can say f dash x is equal to 2 into g dash x. Or you can write here f dash c is equal to 2 into g dash c. This is the sum. 2 into g dash c. There it is, third option. Let us discuss about 7th question. Seventh question. Data he given f of x is equal to x power alpha. X power alpha log x and x greater than 0. Next to 0 given when x is equal to 0. By Rolle's theorem is applicable, and Rolle's theorem applicable for x belongs to 0, 1, then alpha maybe he is giving. Seventh question. This is also depends upon logical thinking. X power alpha, x f of x is given as x power alpha into log x. X power alpha into log x, x greater than 0. Next to 0, x is equal to 0. Rolle's theorem, he is directly saying that Rolle's theorem is applicable. Whenever Rolle's theorem is applicable and given value, the given value x belongs to 0, 1 closed interval. The value x belongs to 0, 1 closed interval he given. Whenever the value x belongs to closed interval 0, 1, there exists at least one value between 0, 1. So x greater than 0 he given for log x and x is equal to 0 he given for 0. 100% he is saying that Rolle's theorem is applicable. Then alpha he is asking. Just logical thinking that logarithm is defined on positive numbers. So here log x merged function with alpha. So since according to domain, I am writing here, since log x is defined, already he given that since log x is defined on positive numbers. Since log x is defined on positive numbers, then we can say here x power alpha. Here alpha also should be positive. Alpha also, because x, whenever x is greater than 0, log x is positive. X belongs to 0, 1. Then you should try to understand that alpha is also positive. He is discussing about alpha. According to options you see, only positive means only fourth option is there. Only fourth option, alpha is equal to 1 by 2. Then alpha may be, he is not deciding, alpha may be according to options only. Next, let us discuss about 8th one. For which interval, 8th question, for interval, for which interval the function x square minus 3x by x minus 1 satisfies all conditions of Rolle's theorem. Interval he is asking, the function he given for 8th question, f of x is equal to x square minus 3x by x minus 1. So let us verify for everything. For which interval he is asking the function x square minus 3x by x minus 1. Let us discuss about domain concept. We know that p by q is rational function, f of x by g of x is rational function where g of x not equal to 0. So f of x minus 1 not equal to 0, x not equal to 1. According to options, 1 should not be there. So first option 0, between 0, 3, 1 is there. So first option is wrong. Minus second option minus 3, 0 is there. Between minus 3, 0, 1 is not there. So maybe second option or third option or fourth option. 1.5 is there. So 1 is not there, it's okay. So let us discuss about, let us calculate about derivative. F dash x I am writing. Using u by v formula, vu dash minus uv dash by v square. 2x minus 3. vu dash minus, this is x square minus 3x. X square minus 3x by x minus 1 whole square. Using the derivative of the given f of x. vu dash minus uv dash by v square equal to 0. vu dash minus uv dash by v square f dash x 0. X minus 1 whole square taken that side. It becomes now, you can write 2x square minus 3x minus 2x. So it is minus 5x plus 3. You can write here minus x square plus 3x equal to 0. So here it is x square minus 2x plus 3 equal to 0. Factors are there. Let us discuss about delta. Delta formula b square minus 4ac. 4 minus 12. Students, this is less than 0. So minus 8. Minus 8 less than 0. Whenever delta less than 0, there is no real value. there is no real value. So function should be exist between real numbers but not complex numbers. So complex roots are there, so no option. I mean here option 4 he given, for no interval he given. Let us discuss ninth one. Between any two real roots, he given here also real roots. The equation e power x sin x. E power x sin x is equal to 1, comma e power x cos x is equal to minus 1. Then how many between any two real roots of equation? At least one root to, exactly one root to, at most one root to, no root he given. At least one root like that. Let us denote the function, multiply with minus 1 here. That implies you write here minus e power x sin x equal to minus 1. And e power x cos x equal to minus 1. Let it be first equation, let it be second equation. Now equate the value 1 equal to 2. As minus 1 equal to minus 1, you can write here the two values are equal. Then you can write here minus e power x sin x is equal to e power x cos x. This minus e power x taken this side. It becomes a plus, you can say here e power x into sin x plus cos x equal to 0. This one taken that side. So e power x is equal to 0, it is not possible. Simply you can say sin x plus cos x is equal to 0. So sin x is equal to minus cos x. Directly you can write x is equal to minus pi by 4. According to option that is verified. X is equal to minus pi by 4. So according to option it is 1 because I am writing here. There is no interval, he given real roots. For real roots I am writing here. For real roots, here I am writing sin x is equal to minus cos x. So you can say here tan x is equal to minus 1. So x is equal to, you can write here minus pi by 4, minus 3 pi by 4, 3 pi by 4, so many like that. So there exist, you can write at least one real root. At least one root. So more than one, so many roots maybe exist according to option, at least one root. Next, 10th question. Now until now we discussed level 2 Rolle's theorem concept. Now we are going to discuss about Lagrange's mean value theorem concept in level 2 classwork. F of x is equal to x minus a whole power m into x minus b whole power n. It's a question. In closed interval a comma b, the function f of x is equal to x minus a whole power m. 10th question. F of x is equal to x minus a whole power m into x minus b whole power n, x minus a whole power m. This is a. X minus a whole power m into x minus b whole power m. In closed interval a comma b, then value of c by Lagrange's mean value theorem. In closed interval a comma b. Yes. Now let us discuss about f dash x. Students, this is uv function. Use the derivative uv dash plus vu dash. X power a whole power m into n into x minus b whole power n minus 1. uv dash completed. vu dash. X minus b whole power n into m into x minus a whole power m minus 1 equal to 0. Now let us take common r, divide by, I am writing here x minus a whole power m minus 1 into x minus b whole power n minus 1. That implies f dash x is equal to x minus a whole power m minus 1 taken common and x minus b whole power n minus 1 taken common. Here you can write this one as n into x minus a, because x minus a whole power m minus 1 taken common. Here x minus b whole power n minus 1 taken common, this one common. So m into x minus b is there, equal to 0. That is equal to nx minus na plus mx minus mb. Why you are writing 0? Don't write, because maybe it is 0, because here I am writing the formula f dash c is equal to f of b minus f of a whole by b minus a is the Lagrange's mean value theorem. So everyone know that b minus b becomes 0 and a minus a becomes 0. So total 0 minus 0 by b minus a. So you write 0 directly. Now 0 we can write. The templates you write here, x taken common, x into m plus n is equal to mb plus na. So according to vectors, x is equal to mb bar plus na bar by m plus n concept we got here. mb plus na by m plus n using section formula. So like that we got the answer. 10th question completed. Next let us discuss about 11th question. 11th one. Let f be differentiable function for all x. F of 1 is equal to 2. Given value f of 1 equal to minus 2 students. Minus 2. And f dash x greater than or equal to 2. X belongs to 1 comma 6. Closed interval 1 comma 6. Then according to option. So by LM we I am writing the formula Lagrange's mean value theorem. F dash c is equal to f of b minus f of a whole by b minus a. F dash x is given as 2. That implies, let us write f dash c greater than or equal to 2 here. F dash c is equal to f of 6. Now we can write f of 6 minus f of 1 whole by 6 minus 1. The value is given as greater than or equal to 2. That implies f of 6 minus f of 1 is given as 2 and greater than or equal to 10, because 6 minus 1 5, 5 to the 10. Now you can say that 2 taken this side, minus 2 be given students, minus 2. So minus 10 it is. It is minus 10. F of 6 minus f of 1 means minus 2. It's okay. F dash 6. This is 2. It's okay. This is 2. But here now you should write here plus 2 greater than or equal to 10. So therefore you can write here f of x greater than or equal to 8. According to options, f of 6 greater than or equal to 8 is second option. Now 11 completed. 12th question. F of x is equal to 4 minus 6 minus x whole power 2 by 3 in 5 comma 7. 4 minus 6 minus x whole power 2 by 3 in 5 comma 7. 12th question. F of x given value as 4 minus 6 minus x whole power 2 by 3 in 5 comma 7. 5 comma 7. F of x is equal to 6 minus x whole power 2 by 3 in 5 comma 7. According to options you should verify. Lagrange's theorem applicable, Rolle's theorem applicable, Lagrange's theorem applicable, but not Rolle's theorem. Both theorems are not applicable. Let us decide the question. First of all, we should calculate whether it is continuous or not. 6 minus x whole power 2 by 3. F of x is equal. Let us discuss about f of x is equal to 4 minus 6 minus x whole power 1 by 3 whole square. So whenever square is there, they let this is y, 4 minus y square. Y 4 minus y square, if it is x, you can take. Let us consider x is equal to y is equal to 4 minus y square. Otherwise 4 minus z square like that. It is continuous curve because x square is there, it has no breaks, so continuous is there. Differentiable, let us discuss about differentiable argument. Now f of 5, differentiable also exists. Let us discuss about f of 5. 4 minus, what is the value? 6 minus 5, 1. 1 power anything? 1. So 4 minus 1 is equal to 3. Next f of 7. F of 7 equal to 6 minus 7 minus 1 power 1 by 3 minus 1 whole square is there. So it becomes plus 1. 4 minus 1 equal to 3. According to Rowe's theorem, it is possible f of 5 is equal to f of 7. Okay. Now let us discuss about f dash x. F dash x depends upon Lagrange's mean value theorem. F dash c is equal to f of b minus f of a by b minus a. 4 minus the value f of 7 is 3, this is 3, 3 minus 3, 0. By Rowe's theorem also you can say 0. So now you can calculate derivative f dash x equal to 0 minus 2 by 3 into 6 minus 6 whole power 2 by 3 minus 1 by 3 into internal derivative minus 1 equal to 0 you write. So minus and minus get cancelled, minus and minus becomes plus. You can write here 6 minus x equal to 0, x equal to 6. So x is equal to 6, 6 lies between 5 comma 7. So both theorems are applicable. Both theorems are applicable. Lagrange's mean value theorem and Rowe's theorem also applicable. But here in option students 12th question, both theorems are not applicable he given. It may be wrong. Once again you verify. We can say that both theorems are applicable. 12th question, 4th option only, but not strike off. Next let us discuss about 13th question. There is no modulus students. 6 minus x whole power 2 by 3. Derivative exists, no doubt it is applicable. Both theorems are applicable there. Next question, 13th question. Value of C of Lagrange's theorem. Value of C of Lagrange's mean value theorem, f of x is equal to 2 plus x cube. 2 plus x cube when condition x less than 1. Next 3x condition x greater than 1. Value of Lagrange's mean value theorem. X derivative 3x square LHD. Anyhow he is saying it is applicable. LHD f dash of 1 minus that is equal to 3x square. 3x square derivative of x is equal to 1 is 3. Yes. Next RHD. RHD is f dash of 1 plus that is equal to 3. Yes. So it is differentiable, no doubt. Now let us discuss about the Lagrange's mean value theorem using this one. LMVT, Lagrange's mean value theorem formula, f dash c is equal to f of b minus f of a whole by b minus a. So f dash c here, 3 you should not write here because you should calculate about derivative. 3x square you write. 3x square is equal to 3x square, otherwise 3c square we can write. The value 3c square is equal to f of b minus f of a. What is the value he given? F of b minus f of a. Oh, he given on minus 1 comma 2 students. He given the value on minus 1 comma 2. So f of b 2 plus 8 x greater than 1. F of b means here 2. 3 into 2. F for x greater than 1, 2 you substitute. Okay. Minus for x less than 1, minus you substitute. 2 plus minus 1 whole cube. 2 plus minus whole by 2 plus 1. The value 3 to the 6 minus 2 minus 1. This is 2 minus 1, 1, 6 minus 1, 5 by 3. 3c square you write here. 3c square equal to 5 by 3. C square is equal to 5 by 9 and C is equal to plus or minus root 5 by 3. First option. Here, while applying the Lagrange's mean value theorem, f of b minus f of a formula, right here, this is A, this is B. This is A, this is B. For x greater than 1, you should apply this one. For x less than 1, you should apply this one. So it is better. Better to try to understand. That is, that there you should apply, for x greater than 1, you should apply 2. And for x less than 1, you should apply minus 1. That is the main concept here. 13th one finished. Let us discuss about 14th one. It is depends upon quadratic expressions topic. Question is easy, but depends upon quadratic expressions. Alpha and beta are two different roots. Alpha less than beta. Alpha and beta are two different roots, alpha and beta. Alpha and beta are two different roots of the quadratic equation ax square plus bx plus c is equal to 0. Then he is asking, then what is the value? Then here depends upon any theorem. Let us discuss this one. F of x is equal to ax square plus bx plus c. Now you write here f dash x. F dash x is equal to 2ax plus b. Alpha, beta both are roots. Then whenever both are roots, this satisfies here ab square plus b beta, a beta square plus b beta plus c equal to 0 and a alpha square plus b alpha plus c equal to 0. 0 minus 0 becomes 0. Then you can write here the value by Lagrange's mean value theorem or Rolle's theorem, the total value is 0. Then you can say here 2ax plus b equal to 0. Then you can say 2ac plus b equal to 0. About f dash c I am discussing. So you can say here c is equal to minus b by 2a. By Rolle's theorem I am writing. By Rolle's theorem. By Rolle's theorem, we can say that small c belongs to open interval a comma b. That implies the value minus b by 2a belongs to alpha comma beta. We can write this one as alpha less than minus b by 2a less than beta. Without doing sum also you can say directly if you know the formula of quadratic expression. Next, how many sums completed? 14 one completed. Let us discuss about 15th one. 15th question. 0 less than, it is also important question. IMP concept. 0 less than, alpha less than, beta less than pi by 2. 0 less than, alpha less than, beta less than pi by 2. And tan beta by tan alpha. And the condition he given as tan beta by tan alpha greater than k. Then k is dash. Then what is the value of k? According to trigonometric function, he given that 0 less than, alpha less than, beta less than pi by 2. So what is the value of 0 less than, alpha less than pi by 2? Meaning itself is there alpha and beta lies between 0 and pi by 2. Meaning itself is the trigonometric functions are in first quadrant. So there is no question of thinking about negative. Everything is positive. So according to tan beta he given. Let the function f of x we can write as x tan x. Because according to options, everything is alpha by beta, beta by alpha, 2 alpha by beta, 2 beta by alpha, like that is there. So using x tan x is alpha tan x, like beta tan x, like that. If we calculate derivative, we will be getting answer. Here, let us write f dash x. F dash x derivative x into derivative of tan x is secant square x, uv dash plus u dash I am writing, and tan x. Because 0 less than alpha less than beta less than pi by 2, everything is positive. Secant square is positive. Then we can say that we can say here the function greater than or equal to 0. That is here positive. So whenever x secant square x plus tan x greater than 0, here whenever it is positive in 0 comma pi by 2. In 0 comma pi by 2. Let us discuss about LMVT. By LMVT function I am writing. By LMVT, f dash x is equal to f of b minus f of a by f of b minus f of a by b minus a. So what is the value of f dash x? X secant square x. X secant square x plus tan x is equal to f of b. Here you can substitute b pi by 2, it is infinity minus 0, x tan x minus 0. So should not get like this. So you can write here beta tan beta. Alpha, let us discuss about no 0, 0 by beta, let only alpha and beta. Between alpha and beta, if we know, you write here beta tan beta minus, let us discuss about this is A and this is B. Beta tan beta minus alpha tan alpha I am writing. Beta tan beta minus alpha tan alpha by beta minus alpha. Why did you write this R? Means to calculate the positive value I had written here. So you can say that this value, this total value is positive. Therefore, you can write here beta tan beta minus alpha tan alpha greater than 0. Now try to understand that beta tan beta greater than alpha tan alpha. Now whatever he is asking, tan beta by tan alpha, that implies you can write here tan beta by tan alpha. Tan beta by tan alpha, this one taken this side and this one taken this side. So it is greater than alpha by beta. Put a box here. Therefore, you can say, conclude that k is equal to alpha by beta. So you should think here A is alpha and B is beta. Depends upon the AB value calculated using Lagrange's mean value theorem. Sir, why did you take an f of x is equal to x tan x? Students get doubted. Depends upon the options alpha, beta, simple alpha, simple beta. For simple alpha, simple beta, I have taken x tan x. While calculating the derivative, we got x tan x derivative is positive. So let us discuss about 16th question. This is somewhat difficult question and important question in mains concept. 16th question. F of x is equal to f of x is equal to alpha 1 less than alpha 1 a1 less than 28 power 1 by 3, a1 less than 28 power 1 by 3 minus 3 less than b1, 28 power 3, 16th one, a1 less than 28 power 1 by 3 minus 3 less than b given. Then a1 comma b1. Then a1 comma b1 equal to dash. a1 less than 28 power 1 by 3 less than minus 3 less than b. Let us consider the function f of x is equal to x power 1 by 3. During errors, rate measure, errors and approximation, and we discussed about approximate value, then we thought like this. According to question, we thought like that 28 based on 28 power 1 by 3 and minus 3 can be written as 27 power 1 by 3. We can say that f of x is equal to x power 1 by 3. Let us discuss about this one. Differentiating both sides. F dash x is equal to 1 by 3 into x power 1 by 3 minus 1. So minus 2 by 3 here. 1 by 3 minus 1 is minus 2 by 3. On I am writing on 27 comma 28 because b minus a concept. So by Lagrange's mean value theorem, by LMVT I am writing here. By LMVT, by Lagrange's mean value theorem, we can say here f dash c 1 by 3 into c power minus 2 by 3 is equal to here f 1 by 3 into 28 power minus 2 by 3 f of here 28 power 1 by 3, not 1 by 3 should not write. 28 power 1 by 3. 28 power 1 by 3 minus 27 power 1 by 3 whole by 28 minus 27. This is the formula f dash equal to f of b minus f of a. You can write here 1 by 3c power 2 by 3 is equal to, you can write here 28 power 1 by 3. 28 power 1 by 3 minus 3 whole by 1. So 1 by, we got the value 1 by 3 into 1 by 3 c power 2 by 3 equal to 28 power 1 by 3 minus 3. Let it be first equation. Next we should discuss about a1 and b1. What is the value of a1 and b1? So let us discuss about the value. We know that I am writing. We know that 27 less than the value x power 1 by 3 according to question. Let us see once now. The question a1 less than 28 power 1 by 3 minus 3 less than b1 he given. We should calculate a1 comma b1. So according to cube roots, the cubic roots we discuss about. So the value c, okay, here a1 we thought as writing here a comma b. A we thought here 27 and b we thought here 28. By Lagrange's mean value theorem or by Rolle's theorem, we can say that the small c belonging between the two values. So you can write here, we know that 27 less than c less than 28. Here I am writing the rise power 1 by 3. For this one I am saying rise power 2 by 3, right? Rise power 2 by 3. 27 you write 3 cube. 3 cube power 2 by 3. You write here less than c power 2 by 3. For this one, for first equation I am writing less than 28 power 2 by 3. 28 power 2 by 3. This can be written as 9. 3 get cancelled. 9 less than c power 2 by 3 less than 28 power 2 by 3. Next step I am saying multiplying. For this one I am calculating. Multiplying 3, you write 3 9s are 27. 27 less than 3 into c power 2 by 3 less than 3 into 28 power 2 by 3. Next, taking reciprocal. This one. Taking reciprocal. You can say that whenever you take reciprocal, 1 by 27 greater than 1 by 27 greater than 1 by 3 into c power 2 by 3 greater than 1 by 3 into 28 power 2 by 3. 1 by 3 into 28 power 2 by 3. That implies whenever taking reciprocals it becomes 1 by this one 3 into, you can write here 1 by 3 into 28 power 2 by 3 less than 1 by 3 c power 2 by 3 less than 1 by 27. Now 1 by the value 1 by 3 into c power 2 by 3. This one from 1 I am writing. The value now we have calculated as the value lies between 1 by 3 into c power 2 by 3 lies between 1 by 3 into 28 power 2 by 3 less than 1 by 27. From 1 I am writing this calculated 1 by 3 into 28 power 1 by 3 less than 28 power 1 by 3. This one you can write minus 3 less than 1 by 27. Everyone know that. Example, let students try to understand that here 28 power 1 by 3 into 1 by 3. 28 power 1 by 3 having some value into 1 by 3 equal to 0.33. Example, let the value may be 0.2. 0.33 into 0.2 something 0.6 like that. That is greater than the value 0.2. So the student try to understand that this one 1 by 28 power 1 by 3 less than 1 by 3 into 28 power 1 by 3 less than 28 power 1 by 3 minus 3 less than, this is 28 power 1 by 3 minus 3 less than 1 by 27. So according to option, let us calculate 1 by 28 comma last value 1 by 28 you write. No need. Again, once again you should write 1 by 28. Why should you write another step? I am writing directly 1 by 28. This value small, this is smaller than this one. Therefore, you can say that A1 is equal to 1 by 28 according to given question here. A1 less than 28 power 1 by 3 minus 3 less than B. A1 equal to 1 by 28 and B1 is equal to 1 by 27. Therefore, here you can conclude that A1 comma B1 is equal to 1 by 28 comma 1 by 27. I am giving homework to you the question. Students, in level 2 homework, is there the question, same model is there. Just you see this question and do the question. Homework, level 2 homework 10th question. Homework I am giving. Just here only you do the question, level 2 homework 10th question. Do the question. I think you can understand the question. Directly also by shortcut also you can do A1 less than 257 1 power 1 by 4 minus 4 less than B1. So what is the fourth root? Nearly according to options 256 fourth root is 4. So here according to options 1 by 257 comma 1 by 256 directly you can say. Otherwise you do the sum. Whenever you can do the sum, then you will be able to understand and you can say practically. Next, let us discuss about 17th question. F of x is equal to cos x. F of x is equal to cos x. 0 less than or equal to x less than or equal to pi by 2 given condition. F of x is equal to cos x. Cos x is a trigonometric function. If necessary, you should not forget about the domains of the cos x. 16th, 17th one. F of x is equal to cos x. F of x equal to cos x, he given as 0 less than or equal to x less than or equal to pi by 2. It indicates that cos x is a positive in first quadrant. Next, he is asking the real number c in mean value theorem. According to LMVT, Lagrange's mean value theorem, the formula f dash c is equal to f of b minus f of a by b minus a. What is the derivative of cos x? Minus sin x. Minus sin c is equal to f of b. Substitute here, this is cos. So substitute the value pi by 2, cos 90 becomes 0 and cos 0 becomes 1 by pi by 2. Here minus and minus will be getting cancelled. Then you can say sin c equal to 2 by pi taken reciprocal, and you can say undoubtedly that c is equal to sin inverse of 2 by pi. That's all. Last question of level 2 classwork, 18th question. According to condition, he given f of b minus f of a. F of b minus f of a is equal to b minus a into f dash of x1. And the condition a less than x1 less than b. If f of x equal to 1 by x, then what is the value of x1? F of x is equal to x1. You should try to understand the value f dash of x1 is equal to, according to Lagrange's mean value theorem, f of b minus f of a by b minus a. So given, according to given condition, he given the value f of x is equal to 1 by x. 1 by x given. Whenever he given f of x is equal to 1 by x, you substitute the value b minus a like that. Now I am writing f dash x. The derivative of 1 by x becomes 1 by minus 1 by x square. That implies you can write here minus 1 by c square. Minus 1 by c square equals, substitute the value 1 by b minus 1 by a whole by b minus a. You take LCM here, a minus b by ab into, you can write here denominator b minus a. This is a minus b. So a minus b will be getting cancelled as minus 1 times through b minus a. That implies we got here minus 1 by c square. Minus 1 by c square equal to minus 1 by ab. Minus minus both sides get cancelled. C square is equal to ab. Therefore c is equal to root ab. In some material he used to give like that a, b, c are in dash, then a, b, c are in GP. Okay students, let us continue in next class. Now we completed module 2, class work completed. Let us discuss level 3 next class.